So, yeah, there's only two. Part 1 and part 2, adding and subtracting rational expressions. Okay, so let's remember. So what this comes down to, okay, I reminded you guys that multiplying and dividing fractions was like very straightforward, right? When you multiply straight across. When you divide, you do the kiss and flip, right? And then multiply straight across, okay? Adding and subtracting. So as soon as you see a plus or a minus sign, adding and subtracting with a fraction like this, okay? The number one thing that you have to remember, we need a common denominator, okay? So that's the twist, that's the plot twist on this one, is we first have to do a common denominator before we can do the addition or subtraction. Okay, so just like here, where we're looking at fractions, okay, when we find a common denominator, we'd like to be nice to ourselves and find the smallest common denominator, right, the smallest thing that's common to both, which means that sometimes you only have to change one fraction, you don't always have to change both. So in this example, we have 5/4 and we want to add 1/8. Okay, so we would choose the common denominator of 8, right? Because 8 likes 8, and 4, we can just multiply it by 2 to get to 8. Okay, so the way that, okay, so the way that it works is, okay, we're going to write an equivalent fraction. We talked about equivalent expressions last week. Okay, and the key thing to remember is what you do to the bottom, you have to do to the top. Okay, so when we write an equivalent fraction, okay, we're going to usually, actually always, we're going to be multiplying the top and bottom by the same number. Okay, the reason why this is equivalent is because what's 2 divided by 2? 1. So in a sense, I haven't actually changed my fraction because I'm just multiplying it by 1. But when I change the numbers, right, I'm making an equivalent fraction. So that's how come we can do this. So I'm going to multiply top and bottom by 2. Okay. And I'm just, for this one, I'm just going to leave my second fraction on its own. Okay, because I'm choosing 8 as my common denominator. So let's, okay, do the multiplication. 5 times 2 is 10. 4 times 2 is 8. Okay, so now I can say how many 8s do I have. So you're just going to add the numerator, and you're going to keep the denominator. Okay, guys, the denominator stays. It does not get added to itself or anything, okay? So we have 11/8, okay? And then we would just double check, can we simplify? And in this case, no, we cannot. This is as simple as it gets. So write a note to yourself, okay? You need to have, okay, a common denominator. Improper is 5. Yeah. Yeah, I don't want it, like, I don't want a mixed number. I don't want you to tell me that there's 1 and 3/8. Like, let's not do that. Let's keep it like this. Yeah. So we need a common denominator, okay? And what you do to the bottom, okay, you do to the top. Okay, whoever, if that teacher's being a little loud with the class, if you want to close the door, you're welcome to. But I can just hear her. Okay. Okay, common denominator, what you do to the bottom, you have to do to the top. Okay, and then we just add our numerators. Okay, guys, let's just do, I don't have room on there, so I'm just going to do it off onto, actually, I'll just make a little page. Let's just do a couple more examples just so that we remember. Let's say I had 2/3 and I want to add 1/2. Okay? Okay. So common denominator of 6. How did I get it? I multiplied the two numbers together to get the common denominator. Okay? So that means when I'm writing this, so what you guys could do is you could, okay, we're going to multiply top and bottom of this one by 3. And we're going to multiply top and bottom of this one by 2. So that I get 4/6, and I'm going to add 3/6. Okay, don't forget that when we have this, we can, right, we can write this all as, like, all with one common denominator because there's 6s. We could also write it like this, all over 6, and combine the numerator. Okay, so that's what we're going to end up doing. We're going to be combining the numerator when we start adding in some variables. Okay, so yeah, in this case, it's 7 over 6. The maturity level in here astounds me.
Well, did you get it? It's 6, 7, 10.
I have kids. I'm good. You guys, all right, that was planned, totally planned. Okay, let's take it back to our notes. Okay, so that's our, just the way that we would with normal fractions, okay, is what we're going to do when we have an expression. So here's our example. There's your expression. Okay, so the first thing we're going to do, okay, we're going to factor it, okay, if possible, okay. Just factor the denominator, okay, because we're looking for a common denominator. So the first thing that we need to do is okay, guys, you have to notice, okay, that the example that we're doing, okay, sorry, part 1, this is part 1, okay, but I'm doing a subtraction example. That's fine. All right, so the questions that we're doing, right, we're doing multiplication and division. Okay, there we go. Okay, so we're going to factor the denominator if possible. So right now my denominator is already a binomial. It's already factored. Okay, so check. We've done that one. We'll do a couple more where we have to do some factoring. State non-permissible values, guys. This still is in effect. Okay, for the whole unit, whenever you see a rational expression, you always have to state the non-permissible values. Okay, so we look over there and we say, okay, so x plus 3 cannot equal 0, therefore x cannot equal -3. Good with that? Okay. Determine a common denominator. Guys, do we have a common denominator? X plus 3, x plus 3. Yeah, it's common already. So this, again, we're doing like baby steps here. We have a common denominator. Okay, it's going to be x plus 3. So now what we're going to do is we're going to write everything over one denominator because it's common, and then we're going to, you guys remember collecting like terms? Okay, yeah. Okay, we're going to simplify. So the thing here to remember is, okay, if it's a plus, right, you can just take all your numbers, right, because you're adding them all. Okay, guys, when this is a negative sign. You have to put brackets around the binomial on the top, because here's what happens. Okay, when we simplify, we have 4x plus 10 subtract 2x plus 4 all over x plus 3. This is what I'm doing, okay? I'm taking the binomial that was on the first one, and I'm just rewriting this, subtract the binomial that was on the second one, all over my common denominator. Okay, so here's the part where, if you're not paying attention, you might miss. This negative sign, we have to distribute it through the brackets, because you're subtracting both of those terms. Okay, so now we want to like drop the brackets so we can collect like terms. When there's a positive in front of the brackets, like if there's no sign, it means there's a positive. That means you can just drop your brackets. We're not doing any sign changes. Okay, so this is 4x plus 10 minus 2x minus 4. Okay, so we subtracted the 2x and we subtracted the 4. Now we can simplify this. Now you can, what they say, collect like terms. So how many x's do we have? We have positive 4, we have negative 2, so altogether we have 2 x's. And then we have 10, subtract 4, that gives us 6. Okay. Now guys, final step, simplify. Okay. Simplify means we might, now that we've collected all of our terms, we might now need to factor it. Okay. And then up here, 2x plus 6, could we pull out a GCF? Yeah, do we need to pull out the GCF? Yeah, we do. Yeah, you're hoping I'd say no, we don't have to? No, you do. So we're going to take out the 2. That gives us an x plus 3. And look at that, we have an x plus 3 on the bottom. So we can actually simplify it. And our final answer here is just 2. Everything else okay, canceled, and we end up with just 2. Okay, so our answer here would be 2, but we'd still have a comma and say x cannot equal -3. Okay, and you might think that that looks a little weird because, like, well, there is no x anymore. But the original question had an x, so we still have to put the non-permissible values next to our answer. Okay, so let's do a couple of these. So let's start, okay, with some that already have common denominators, just to kind of practice collecting like terms and simplifying. Okay, so for this one, we have, okay, we have 2x over 3, and we have plus an x over 3. So we have a common denominator, so we can combine the numerator and put, sorry, that's an x. My eraser, x. Okay, and we can put that all over the same denominator, okay, because we already have common denominators. So we just do the addition on top, okay? Now we need to simplify. We're going to pull an x out, and we have, wow, my brain just stopped. Oh, guys, we don't have to pull an x out. How many x's do we have? 3, thank you. 3x over 3, okay? And now we can simplify, okay? 3 divided by 3 is just 1. Okay, so our answer is 1x, or we don't have to write the 1, we can just write x. Okay, are there any restrictions on this? Why not? Yeah. Okay, did you all see that? There's no restrictions on this because the denominator was 3. Okay, there's no variables on the bottom, so there's no restrictions. So this would be our final answer. Good job, guys. Okay. Okay, so now this one. The next one is the same kind of thing. We have a common denominator already set up for us. I want to make sure that you guys caught what happens when we do subtraction. Okay, so set it up. Okay, you're going to subtract the numerators over the common denominator. Okay, so if you're feeling like you get this, you work ahead of me and then you can just check in. Okay, so I'm going to put my binomials in brackets so that I can see, and this is all over 6. Okay. Don't forget to distribute the negative through the brackets. Okay, so we have 5y minus 1 minus 4y minus 7 all over 6. Okay, which gives us y minus 8 all over 6. Okay, can we simplify that anymore? No, we can't. Okay, because we have a binomial on top and we have just a number on the bottom, so there's no more canceling, there's no more simplifying. Okay, and I heard someone kind of whispering over there, and they're like, there's no restrictions on this one either. Okay, you're right, because the denominator is 6. Okay, so no restrictions on this one. All right. Okay, so this next one, okay, we don't have common denominators, so that's our first step. Okay, what common denominator would you choose? Oh, you get a question?
Yeah, -1 minus -7.
No.
Yeah.
No. -1 minus 7. Okay, -1 minus 7.
No, it's like -7. It's like because minus, and then you also have the negative.
No, I took care of that.
No.
Okay, minus +7 becomes -7. But you, no, okay, once I've done this, it becomes just a -7. -1 minus 7. -1 minus +7. Yeah. Okay, but guys, this is, you know what? This is awesome. You've got to clear up any questions that you have. Okay, be brave if you have a question. Okay, because chances are someone else has a question just like it. Okay, and we're helping each other. Okay, so this one, okay, this one we need a common denominator. Somebody tell me what they chose. 6. Okay, I like that. I would choose 6 as well. Okay, so just With these, kind of like spread out your answer a little bit just to give yourself enough room, like when you're rewriting it. So I would go 3a minus 1 over 3, okay? And then I would say, okay, I'm going to multiply top and bottom by 2, okay? So don't forget your binomial that's on top, put it in brackets. And then we can continue on with our 4a plus 5 over 6. Okay, guys, do we have any NPVs? Nope, there's no variables on the bottom, so no restrictions on this one either. Okay, so now what you're going to do is you're going to distribute the 2 through the brackets. Okay, is it okay that the 2 is behind the brackets? Sure. Okay, if you would rather write the 2 in front of the brackets, like if this makes you happier, if we had, and I've lost my question, 3a minus 1 all over 3. If you want to put the 2 out in front so that the 2 is in front because you're used to seeing it that way, that's okay. I want you to be comfortable with being able to interchange if the 2 is in the front or if the 2 is, whoop, I'm still on the right page. I just have to go back. Okay, so I just put the 2 behind because that's where I wrote it, but I still have to distribute it. Okay, so once I have that, okay, 3a times 2, so that gives me 6a minus 2. Guys, I'm adding. So if I'm adding, I can just write the other binomial as it is. And all of this is going to be over my common denominator of 6. Okay, now go ahead and collect like terms and simplify. Okay, so I have 6a and another 4a, so we should have 10a. I have negative 2 plus 5, so I should have plus 3 all over 6. Okay, is there any GCF I can take out of the top? No, there's not. Okay, so this one is as simple as it gets. Okay, and I'm being a little bit lazy here, guys. Make sure you put equals. Okay, because these are all equivalent fractions when we're solving. We put equals all the way down the left so that when we have our answer, we can see what the answer is, and that's what it equals. Okay. All right, next one. Oh, we've got a 3 and an 8. Okay, what's my common denominator? Okay, anybody else? Common denominator, guys? 24. Okay, how'd you get it? 8 times 3. Okay, so if you're not sure, just multiply the denominators. Okay, so again, we're going to use lots of room. Okay, I'm going to write my 8y minus 3 in brackets over 8. Okay, and I'm going to subtract. Okay, I'm just going to write it like this first. I'm just rewriting it. Okay, so you can decide where you want to show the multiplication. You can show it in front, like that, okay? Or you could, if you wanted to, okay, do it, okay, behind, okay, or in front. Okay, let's just be consistent for this one. I'm just going to write them both in front so we can see what that looks like. Okay, when you write that, don't forget, put brackets around your binomial. Okay, so now what happens is we're just going to distribute the 3 through the brackets. We're going to, okay, so 24y minus 9. Okay, guys, when we distribute this one, okay, we're going to distribute a negative 8 through the brackets. Take the sign with you. Okay, so this becomes minus 16y minus 8. Okay, just like in this question where we had to distribute the negative. Okay, the negative is just attached to the 8, so you're going to distribute a negative 8 through the brackets. And then it's all over our common denominator of 24. Okay, any NPVs on this one yet? Nope. Okay, we still just have a number on the bottom, so no restrictions. Now we're going to collect like terms. 24y's, subtract 16. Okay, that looks like 8, yes, I agree. Okay, -9 minus 8 should give me -17 all over 24. Can I simplify that anymore? Is there a GCF I can take out of the top? No. Okay, so that is my final answer. Okay, you understand? You had a question? Oh, keep it just till after lesson. Okay. So you understand like the mechanics here, right? So if there's a subtraction, okay, we have to make sure that we take that subtraction through the brackets. So now what we're going to do is we're just going to add a little bit to the denominator. Okay, we're going to make it a little bit more interesting by, okay, adding an unknown. Okay, adding a variable. So again, we're going to like so today's like the baby steps, and then tomorrow we're just gonna like give you a whole bunch of combination stuff. Okay, so if today you're like, this is so easy, okay, it'll still be good tomorrow, but it'll be a little bit more. Okay, so because I'm looking at these ones and they're so far like like we have common denominators. Okay, however, don't forget we're going to state non-permissible values when we do this. Okay, so for this one, I can look at it and I'm like, oh, they gave us common denominators. Awesome. So I can just say, I can state my non-permissible value. X can't be 0. Okay. So because I have common denominators, I can just combine the numerator. So I have a 2, I have a +7, and I have a -1 all over X. Are we good with that? 2 + 7 - 1. Okay. So that would be 8 over X. And X cannot equal 0. All right, go to the next one. Okay, common denominator, awesome. What's our non-permissible value? Yeah, it cannot equal 0. Okay, we don't have a problem with the 2. It's just the A. Okay, the A is on the bottom, so it cannot equal 0. So for this one, we can, because we have a common denominator, we rewrite the numerator all together. Okay, and then collect like terms. So we have 5A, so we have 6A, and then we have -3. Okay, can we simplify? Yes, yes. Okay, we can take a GCF out of the top. So let's go ahead and take out a 3. Okay, it didn't further simplify on the bottom, but that's okay. Okay, it is completely simplified, and so this is going to be our final answer. Okay, guys, why can't we like cancel the 2A and the 2A? Yeah. Okay, so don't forget, this is a monomial on the bottom. It's just one term. Okay, this in brackets is a binomial. That 2A is attached with the -1. You can only cancel out if your brackets are exactly the same. All right. So let's make sure that we catch the negative sign when we're subtracting. Again, we have common denominators. So this time our NPV, okay, you set your denominator equal to, not equal to 0. Okay, so we have 3y is equal to 1. Okay, y cannot equal 1/3. Okay, because I did this, +1 and +1. There we go. I showed all my work there. My pluses are looking a little. There, okay. So when we have a common denominator, let's go ahead, 3y, we're subtracting 1, and then 3y subtract 1. Oh, interesting. Okay, guys, look at this. Okay, I have 3y - 1 on the top and 3y - 1 on the bottom. Can I cancel those? Yeah. What's my answer? Good. Answer is 1, okay, not 0. Because this, okay, When you cancel, you're canceling it because you're dividing, and whenever you have a number like 7 divided by 7, that is equal to 1. Okay, 3y minus 1 divided by 3 minus 1 is 1. Okay, and so then we would just have our restriction here. Okay, so that's our final answer. Okay, if you're feeling good, go for D. Okay, state your, so again, first you would look at it and you would say, okay, I need to factor my denominator. It's factored. Okay, then I state my non-permissible values. Okay, then I find a common denominator. It's already common. And then I can go ahead and, okay, make a common numerator and collect like terms. So in this case, we have 4x minus 5 cannot equal 0. So x cannot equal 5 over 4. Okay, that's the summary. We have, okay, we have x plus 2, and I'm just going to write it out in 2 steps. Okay, 4x plus 5. So don't forget, because it's subtraction, okay, that negative sign has to be distributed. So whether you write it all out in like this, or you just can like see that you're distributing at this point, okay, and then that kind of saves you a line. Okay, but either way, we've got x plus 2 minus 2x minus 4 all over 4x plus 5. And the x's do we have? We have a negative x and we have a negative 2. Okay, so this, I would say, is an okay answer. If you want it to be like the absolute best answer, we would actually take out what's common between the top. Both terms are negative. We would actually take out the negative. Yeah, we would take out the negative 1. Why do we do that? It's a math convention. Okay, it's a math thing. We always want like the leading. We always want the number in front of x to be positive. So if there's a negative in front of it, we take the negative out and put it outside of the brackets. Okay, that's why we do it. Okay, and then here we would just write our restriction. Whoops. Guys, I wrote this like wrong every single step and nobody like, Mrs. Branch, the question is a minus sign. There we go. Okay, a little typo there. So that would make my, I just correct the first time when I did my non-permissible value. There we go. Okay, it did not magically transform into a positive. That was just me being hasty in my writing. Okay, so it stayed 4x minus 5. Okay, and then we simplified. Okay, we'll do one more together and we'll get you guys up and out of your seats and do a little bit of board work. Okay, practice these. Okay, what happens? Okay, guys, what is the best common denominator for this next question? What do you think? 21p. Okay, did you get that she didn't say 21p squared? Okay, because they both already have a p, so we don't need to double up on the p's. Okay, because you want to choose like the lowest common denominator. Okay, so in this case, right, I'm going to have 5, 3p plus 2 over 7p. I'm going to multiply this by 7, and I'm going to multiply this by 3, so that I get 35 plus 6 all over 21p, which then gives me 41 over 21p. Okay, that looks really messy. Give me a sec. Clean that up. Raise that up, clean it up. Here we go. 41 over 21p. Okay, can we simplify 41 over 21? Okay, if you're not sure, don't forget, you can pop over to your calculator. You can do 41. Just give me a sec. You can do your stacked fraction. Okay, and you can do 41 over 21. Okay, nope, didn't change, so that means it's simplified form. Okay, so some of these you can do mental math, you can do them in your head, you just know what it simplifies down to. For some of the weirder numbers, you could also use your calculator, have it help you make sure that it's in simplest form. Okay, oh, I didn't mention, when we went up here, what was our non-permissible value? Somebody showed it out. Yeah, you guys are getting solid with that. Okay. All right. So let's do the next three. If you like, I'm going to keep them up here, but if you want to take your notes with you, we're going to do these on the board, and then you can fill in your notes once you've worked it out with your group. So head up to the boards and let's do B.